Okay. So log rule for integration we'll do this. So let u be a differentiable function of x. So the rule number one is the integral of 1 over x dx is equal to ln of x plus c. Number two, integration of 1 over u du is also ln u plus c. Alternatively, if you see the derivative and the original on the bottom, then this should be ln u plus c. Okay. All right. Let's do a simple example first. So the integral of 2 over x dx. Remember, we can pull out the 2 in front. And we know that the integral of this will be 2 times ln of x plus your c. So 2 ln x plus c. Although, we know that the property of log says we can pull that power, or that coefficient, and make it a power, right? Using the power rule for logarithms. Is there any question on this example?
Is it still absolute value?
It's no longer needed because it's being squared.
Oh, you're right.
I'm so late. Just I'm having problems getting in.
Oh, it's okay. No worries.
What did I miss?
We just wrote down these identities or formulas, and then we started this first example.
So
we're doing integration of logs. What's up?
Just like another question regarding the 2 in the first place, like when you have the integral and you're basically putting it on the left side of the symbol and replacing it with 1. Is that like a rule, or I'm not understanding?
Right here?
Yeah.
Yeah, remember how we can pull out any constant outside the integral symbol.
Oh, okay.
Then we integrate this. Kind of like when we did the sums and you pulled out some number, and then you deal with it. And then after that, you multiply the 2 out.
Okay.
Okay. Let's find another one. Okay. Example 2. Use, you know what, I'm just gonna write it. Integral of 1 over 4x minus 1. dx. So this whole section is about log rules, right? So we can cheat and try to force this to be a log question. All we got to do is do a u sub of the bottom in order for us to use our log property or log formula. So let u equal 4x minus 1. Du will be 4 dx. There is no 4 in the question, so divide it out. So now I will have the integral of 1 over u du over 4 using our substitution. And then we pull out the 1/4 that's on the du, and we can just straight up use our integral formula. This will be ln u. And then we just resub u and we're done.
These are all logarithm or natural log formulas.
They're all going to be log type. Mm-hmm.
Professor, in the exam, if someone, for example, solves this problem using another technique or another solution, but not this rule, for example, it will count right or wrong?
If you find another technique, I don't think there is another one for this guy, but I will not mark you wrong unless I tell you to use a specific one. If I just say integrate, then you do whatever, as long as it's an appropriate technique, which doesn't matter.
Okay, just asking.
Mm-hmm. No, that's a good question. I'm not gonna, most likely I'm just gonna give you a bunch of questions and you integrate however you want. Okay. Right. Let's go to something a little bit different. You guys cool on that other page, or do you want me to wait?
Good so far.
Alrighty, so finding area. Okay, so question will be, I'll just write the question here instead. Find the area underneath the region. Actually, that sounds weird. I'll say of instead. Sorry about that. Find the area of the region bounded by the graph y equals x over x squared plus 1, and the x-axis and the line x equals to 3. So It might help to graph this guy and see what we're dealing with, right? So y equals x over x squared plus 1. Oops, let me show you my graph. Okay. So here's x squared plus 1. This is bounded by the x-axis, so down here, and x equals to 3, right? Okay. So they want this region right here. I don't know if I can shade that or not, but it's not good. So I'm integrating this function, right? And I want this area. So how do you build that integral? What are the bounds of the integral?
X equals 0 and x equals 3.
Yeah, I think that's what we're gonna do. Integral from 0 to 3 of this function. So you have to figure out what are the bounds by looking at the graph. Okay. So you need to be able to graph them or look what they know what they look like, or look at a graphing calculator to help you out. So once we're here, it's not that we're back to what we've been doing, right? So how do we integrate that?
Can we do the chain rule?
No, we're not. It's not a derivative, right?
No. So then.
So far, we only have a couple of techniques, right? We got basic power rule, and we got the U sub, and then now we have this log rule, right? If we can't do a power rule, then we got to look into U sub. If we can't do the logarithm straight up, then yeah, we got to see, will U substitution help us out? So what should U be?
X squared plus 1.
Yeah, it's going to be x squared plus 1 du 2x dx. Again, we don't have a 2, right? We'll get rid of it. So du over 2 is equal to x dx. So this guy will be replaced by this. Okay. So now we have du over 2 over u from 0 to 3. Although right now it looks super weird, but who cares? We can pull that 2 out in front, right? Or rather, 1/2. So what will be our answer? For the integration, I should say.
The u would be x squared plus 1.
Well, you got to integrate first before you sub it, resub.
Oh,
It would be the. You're just inserting the 3 into the original thingies now, right? After you've substituted.
Well, first we sub, and then we find the antiderivative.
I have a question here, very quick.
Mm-hmm.
So when we say du over 2 over u, the u it should be go up and multiply by the du, like the denominator of the denominator is numerator. Like there's a rule saying that the u have to be multiplied by the du.
You can, but it'll be the same thing.
Okay.
You see?
Uh, I can see very well. How can you explain very quick?
Yeah, no problem. So you're saying we should flip the bottom part and multiply, right?
Yes.
So then we end up with this, right?
Oh, I was thinking that multiply by the inverse, not by 1 over u. Multiply by u.
This is u over 1. The reciprocal would be this.
Got you. Thank you.
Yeah, no problem. There's our little side work there. That's a good question because it does look weird, right? But technically, we're pulling out a half. So you can think of it this way, which is okay because we should understand fractions, or you can just think of it as some number that I'm factoring out.
Got
Doesn't
you.
matter. Doesn't matter. So then we get, so at this point we apply our logs, right? This is going to be ln u from 0 to 3, but we got to change it to x first. Ln of x squared plus 1. Okay. Okay. So far, you guys okay? All right. So then just plug in the values and we should be good. We'll find the area. That's what we're looking for. The area in that blocked off region. Okay. So we'll have 1/2 times ln of 3 squared plus 1 minus ln of 0 squared plus 1, which will be ln of 10 minus ln of 1, right? Into 10. So this is going to be 0, right? But who cares? We'll have ln of 10. Which is some number, right? We don't really need the absolute at this point because we know 10 is positive, correct? Let's see. There we go. Yeah, that's what matters, right? Who cares about the answer? All right, so we need to do a use of in order to solve this. So let's let u equal the denominator, right? Usually that's a good choice because it's a higher power and most of the time it's going to be on the bottom, especially if you're doing log stuff. But not always. So du will be 3x squared plus 1. And that's right there, right? Cool. So then this becomes an easy question of du over u because it's exact sub. So then integrate du over u, which will be ln of u, which is really ln of x cubed plus x plus c. Any questions about part A?
No.
Okay, let's do a harder one. Let's go back to trig questions. These are the fun questions. Okay. So, what do you think is a good sub for you?
10x.
Yeah, let's do tan x. What is the derivative of tangent x?
Secant squared x.
Yeah, it's secant squared. dx. So then, it's going to be a straight up sub. So du's on top, u's on the bottom, which gives us ln of u plus c, which is really ln of tangent x plus c. So once you do the sub, it's not too bad, right?
Mm,
Is there any questions about this? I'll just try and make it look prettier. Okay. All right. Let's move on to something else. Oh, this one's gonna be cool. I might need a whole page for this one. Do you remember your long division from either high school level or maybe college algebra? Well, let's do an easy one first with numbers. If I divide 5 into, I don't know, 595, the pattern, right? We first look at the first one. 5 goes into 5 one time, right? 1 times 5. And you put a minus and subtract. Then you bring down the 9. 5 goes into 9 one time. 1 times 5. You put a minus, right? You guys remember this?
yes.
Bring down the 5. 5 into 45 is 9. So that's long division with numbers. I'm assuming everybody remembers that. The question that I'm asking though is, do you remember long division with algebraic terms? Because you
Not
cannot
really.
solve this unless you divide it first. So we're going to use this pattern to guide us, because it's really the same deal. There's just a few differences, okay? So x squared plus 1 is dividing into x squared plus x plus 1, right? That's what the fraction means. So what you're going to do is use the first term to do your division. Okay, I'm going to make another scratch box over here. So x squared goes into x squared how many times? Right? One time. Then you do 1 times both of these. And you subtract them both. Okay. So x squared minus x squared is 0. I can subtract the 1's, but not the x. So that's going to be, these 1's cancel, leaving me with plus x. And that's as far as I can go because x squared does not go into x. So how do you write the remainder?
X.
This is equal to 1 plus a remainder over the divisor, remember? Like if you had a remainder here, you would put that over the 5 and you'd have some decimal piece, right? Some fractional piece. So I'm going to integrate this instead of this because they are equal. So the integration of x squared plus x plus 1 over x squared plus 1 dx is equal to the integration of 1 dx plus the integration of x over x squared plus 1 dx. Using this, using our algebra. So then, this is no problem, right? It's just an x. Who cares? This guy will require u sub, although we did that earlier. Remember? On example 3, it's the exact same question. So I'm just going to copy paste because who cares? We got ln of 1/2 ln x squared plus 1. Technically, just write you a note requires u sub. Look at example 3. It's the exact same problem for that little piece. Are there any questions on this example? Example 5. Do you remember the long division?
Yeah.
Okay. Okay, so change tangent, take the correct sub, and then deal with this minus sign. So just pull out the minus in front. And this will be negative ln of u, right? Which is negative ln of cosine. Are there any questions about this problem here? I'll give you some formulas for the trig functions. But if you ever forget, there are ways to derive them. So here's the integral of sine x dx will equal negative cosine x plus c. Integral of cosine x dx will equal sine x plus c. Integral of tangent, we just did that, would be negative ln cosine x plus c. Integral of cotangent x dx will equal negative, no, it's positive, ln of sine x plus c. Integral of secant. Deriving secant is one of the hard ones, but I won't make you do it. You can use these formulas if you want to. Integral of cosecant is negative ln of cosecant x plus cotangent x. There you go. So these are all the trig functions you're going to need for integration. This is an easy one. So a little formula there. Formula section.
For the integral of secant, is there a constant at the end of that one?
Oh yeah, always should be.
Okay, sorry.
Unless it's definite integral, we should always put that c. I just realized it's getting dark in here. Okay. So that's square root of 1 plus tangent squared. What is 1 plus tangent squared back in pre-cal? Do you remember?
Sorry, what was the question?
How can we rewrite 1 plus tangent squared?
Can you substitute?
Yeah, you can. We need our trig identities, the Pythagorean identities. Remember how there was like 9 formulas we derived from this guy? Right? Remember this one, right?
Yes.
So this one can create 9 more. And I'm going to save time here. Eventually you find that secant squared is equal to 1 plus tangent. So we need to have those handy because trig is going to come up a lot in Cal 2. All right, so then you can sub this guy, right? So that would be just a secant. Which will be, according to our formulas we just wrote, that will be ln secant x plus tangent x from 0 to pi over 4. Okay. You guys have any questions on this? I'm going to skip this number step. whatever, not a space. Yeah, that's right. 0.88. Yeah, 0.1. Any steps here from this question or the last question that don't make sense? Okay. Want to move on to inverse trig then. Section 5.8. Yeah. This will be the last section for today and the last section for your test. Integrals involving inverse trig functions. Do you remember the derivatives of the inverse trig functions? All right, pull up a random page here. There we go. So remember these guys, right? Derivative arc sine or sine inverse, whatever, however you prefer to write it, is equal to this. Arc cosine was similar, but with a minus sign. Do these look familiar?
Yes.
Okay, so these are all from Taiwan. So, let me see. Yeah, I'll just write them. I'll write them down for you. That way you have them, and we can refer to them. So I'm gonna use arc sine just because I'm tired of the inverse symbol. So that would be square root of 1 minus x squared. Derivative of arc cosine would be negative, the same thing. The derivative of tangent, arc tangent, that will be equal to 1 over 1 plus x squared. Derivative of arc cotangent, the same deal but with a minus. All right. Derivative of secant, arc secant, is going to be 1 over absolute value of x times the square root of x squared minus 1. The arc cosecant will be 1 over okay, with a minus. So obviously, if I integrate, we'll go the other direction, right? Okay. Here are the first three general formulas. So the integral of du over the square root of a squared minus u squared is equal to arc sine of u over a plus c. Number two, the integral of du over 1a squared plus u squared is equal to arc tangent of u over a. I'll put that in parentheses. Number three, integral of du over u square root of u squared minus a squared, which is equal to 1 over a arc secant of absolute value u over a. All right. So basically, you have to either identify that it is a trig type sub, either do a substitution or a factorization to help you out. Okay. Use another list of formulas here. So, for example, the next few would just be integration with inverse trig functions. So the integration of dx over the square root of 4 minus x squared is equal to arc sine of x over, oh, sorry, doing it again. We got to figure it out. All right. So I gave it away a little bit. It's supposed to be arc sine, but how do we get there, right? We can factor or rewrite that 4 so it looks like number 1, right? But technically what we can do is say that 4 is 2 squared minus an x squared. So look at number 1, we have some a, some number, minus some variable. That will give us arc sine of x over 2. We just need to be able to tell that this is a arc sine question, right? You see what I mean? Because I might not tell you. You might look at it and think, oh, maybe I should try a sub or something. But you don't have to. Are there any questions on part A? Okay, let's keep going then. Part B. No, actually, no, it's been a while. Let's take a little break. 9/11, come back at 9:15-ish, 16. All right, for the next question, we need to figure out, okay, what type of problem is it? Since we're in the trig section, well, we should know it has to be one of these trig types. So try rewriting the problem. So it looks like it could be a tangent because you see a plus down here. And I don't see any roots because number 1 and number 3 you have square roots. So most likely it's a tangent if I can rewrite it this way. Okay, so this will become dx over. So I need to have something squared plus something squared. So I need to rewrite this as a root 2 squared plus 3x squared. So now we have our a squared plus u squared, right? This will become tangent, sorry, arctangent of u, which is 3x over root 2. So sometimes you have to do some little bit of algebra to make it work.
So you did the radical square root of 2 raised to 2.
Yeah, so root 2 squared is going to be 2. So I rewrote this as a square. I'm kind of forcing it.
It's just because not because the 2 was a square root, it was just we're forcing it to be a
We want to make it look like something squared plus something else squared, right? So that's what I did here. This guy was easy because there was already 2 squares, right? So this one wasn't clear, so we had to rewrite it. Okay, so the integral of dx over the square root of e to the 2x minus 1. How should we approach this? So it's going to be the trig sub because that's the section. So we're going to use 1, 2, or 3. Which one do you think it probably is?
Third one.
Yeah, I think it's going to be number 1. Maybe. Although, if you look at 1, the number is squared minus the variable. We have some weird variable minus a number. So I think it's going to have to be 3.
3.
Yeah. But 3 needs a variable right outside the root. So we're going to have to figure out how that's going to happen. What is a good U substitution?
ULN.
What's that?
I was thinking we could use ULN.
ln, no, because we have that root. Can't do it. So we will have to do you have to deal with this e. So remember, e2x means e to the x squared, right? You agree with that?
Yeah.
Yes.
Yes.
So if I let u equal e to the x, then du would be equal to ex dx, right?
Yes.
Yes.
But there is no ex in the question, so I'd have to divide that weirdness out. Well, that's not going to help me, is it? So, no, actually, I will. I wrote that weird. This is a weird question, but I think it's going to work out. Can you read that? No, I thought that messed up. So we said u is ex, right?
Yeah.
So this is really what? Du over u, isn't it?
Yes.
So
Mm.
that means that we have du over u over square root of u squared minus 1. Let me write that better. No, that looks funky, right? The symbols all mixed up. Which then will give us du over u square root of u squared minus 1. So there it is. It wasn't obvious at all, but we did have a hint that it should be number 3 because the variable part was first. Then we get arc secant of e to the x. Let me write it down here. No space. Arc secant of u.
So the one doesn't need to have a square either, a root above it,
What's that?
where you said u squared minus 1.
Mm-hmm.
It doesn't have to have a two to the 1 to the power, second power for that one. Or no, it doesn't matter.
You're wondering, so this right here is set up to be number 1. So you can do the straight up integration to here. But is that, what was your question exactly? You said something about the square and the root. I didn't catch it.
I was looking at the number 3, how you have u, the square root of u squared minus
Oh, that's an a squared there. That's just some number.
the a squared. So here you have u square root of u2 minus 1. Wouldn't that 1 be squared or no?
Yes, technically, we can rewrite that as a square, and we should to be consistent. But it doesn't make a difference, right? Because it's just a 1.
Yeah, I understand. I'm just trying to grasp it 100%. Thank you.
Yeah, no, yeah, it's a good idea. We should write it. So the u over a goes here, right? U over 1. U squared minus a squared. So it goes right there. So then plug in the u and we're done. Is there any other questions on this problem?
No.
Excuse me. All right. Example 3 is x plus 2 over the square root of 4 minus x squared. So it's probably going to be number what? Number 1. Yeah. But we have a bunch of stuff on top, so let's fix that first. So we can separate the fraction, right? So this is a fraction being added together as x over the root 4 minus x squared dx plus the integral of 2 over the root of 4 minus x squared dx. So this guy, I think it's just going to be a u sub. This one will be a trig solution, an arc sine, right? So let's do this piece by piece. So for this guy, let's do them separately. Let u equal 4 minus x squared. Let du equal negative 2x dx. So du over negative 2 will be x dx. That was no big deal, right? So I'm not going to put equals there because that's not true. I was working on these separately. So then this will give me a negative du over 2 over the square root of u, which is negative 1/2 integral of du over root u, which is just going to be u to the negative 1/2. So just a basic power rule, right? So this is not too bad. So then we will get, you add plus 1, divide by that. So that will be negative 1/2 u to the 1/2 over 1/2 plus c. So our answer will be negative u to the 1/2 plus c, which is really negative 4 minus x squared plus c.
We gotta put the radical back up.
Yeah, it's 1/2. You don't have to, but I went ahead and did it because the power is 1/2 here.
Okay, I see.
So the first piece is u sub from from Monday, or maybe last week, I forget. So that's one piece right here. Now let's do the integral of 2 over the square root of 4 minus x squared dx. So pull out the 2 and rewrite the question. So this is going to be a 2 squared minus a x squared dx, which is equal to which one?
Plus 1.
Yeah, arc 2 arc sine of x over 2, I believe. Mistakes. Look at our formula to be safe. Yeah, u over a. So we will get arc sine of u, sorry, x. X over 2 plus c. So our final answer, go back to the top here. This answer will be negative square root 4 minus x squared plus arc sine of x over 2 plus c. Right? Because we're going to tack on this guy and this guy. Then integrate them separately. So we'll call this number 1 and number 2, just to be a little bit more neat. Here's number 1, and here is number 2.
Raise it up a little, please.
Okay, so integrate number 1 here, and then number 2 there. You put them together up top. Do you guys remember how to complete the square?
A square minus b square, something like that.
So we take this guy here, and we try to make it into a perfect square. So in order to do so, you look at the middle term, which is 4, take half of it and square it and add it to this guy. But before we do that, I'm going to make a missing piece here so it's obvious. Completing the square means I'm going to add something to it, but then I have to subtract that same something. Okay, so half of 4 squared is 4, right?
Right.
But I can't just, since I don't have an equation, I can't just add something for no reason. There's no 2 sides, so I need to subtract what I did. Trying to game the system here. So then this is a perfect square, which factors into this guy. And then I have 7 plus 4, which is just a plus 3. So this bottom part can be rewritten as x minus 2 squared plus 3. Does that make sense?
Yeah.
Yes.
So then just, so which arc function do you think this is?
Third one.
Yeah, I think, no. The one with the plus. I think it's number 2, right? I believe this is going to be the tangent. So we have to rewrite it as a sum of 2 squares on the bottom. This is already a square, so that's cool. This one needs to be rewritten as a square to force the formula. So then this will become arc tangent of, let's double check it for you. It's x over u over a here. X minus 2 over root 3. Just at first glance, it wasn't obvious that this was a trig integration. And it should work out. So once you do the sub, pull out the 1/8, Where's the button? ln of e to u du. But before we integrate, ln and e are inverse functions. So they will cancel each other out at this point. You actually could have canceled before we started. So this will become 1/8 u squared over 2 plus c, which would become 1/16 u squared plus c, which is really 8x minus 8 squared over 16.
Let's see.
Yeah, sorry, yeah, scratching.
I see I made a mistake. I made it up here at the top right here.
Huh?
My mistake. I made it up on a little earlier.
You picked a bad sub or what?
No, I picked the 8x, but I also had the e included.
Oh, okay.
That's why I made the mistake. So just using the 8x minus 8. I didn't think I could do that. I thought I had to take the whole equation there to make it the u. I didn't think I could just use the exponent portion.
Yeah, let me double check something. Yeah, that'll be fine. I mean, you could expand this a little bit more, but it doesn't really matter. Because you could just say that that's going to be 64x squared plus, well, minus rather. Minus 8 times 8 is 64, we get 128x plus 64. Divide it all by 16, that should give us what? 4x squared minus 120 divided by 16, what is that?
8.
Yeah, that's right. Should be right.
Okay, so
But I was thinking an easier route would have been to just skip all this. E squared. So these cancel at the beginning.
the ln and the e.
Yeah. So this would just be 8x minus 8 dx. It should be 4x squared minus 8x plus
Raise it
8.
up.
Yeah. So I think this path is better.
Oh, okay.
And if you're wondering what the hell's up with the 4, this is, you add them together and that's still C, so it doesn't matter.
All right.
Um,
That was-
Professor,
What's up?
I have the problem that I have is the integration of
You have another one? What is it? Integration of,
x over
okay.
square root of 8 minus 2x squared, all under the root. 8 minus x squared, yeah, no, not 2, just x squared, no 2. Dx.
X squared dx.
Yes.
Okay.
The problem when I see there is a like watch it, how to watch the result. I watched the result and I didn't get, he took half out, like a half out, and put 2 before the dx. I didn't get this step at all. Like I don't know how he get half an outside and 2 inside. Can you solve it for me?
Yeah, we can do it. I mean, I don't know what solution you saw, but let's figure out a way to do this. I'm pretty sure there's going to be u sub, right? This is the u sub section. If I do du, that should be negative 2x. I don't have a negative 2x or negative 2, so divide it by negative 2, and I can sub this. Negative du over 2 over square root u, right? Which will be negative 1/2 integral of du over u 1/2, right? Which will be negative 1/2 integral of u negative 1/2 du, which will be a power rule. The answer would become negative 1/2 u to the negative 1/2 plus 1 over negative 1/2 plus 1. So at that point, you'd get what? Negative u to the 1/2 plus c, which is negative square root of 8 minus x squared plus c. You should get this.
Okay, my question is, when we say equal negative half du over u power half, how we get the negative half outside?
Yeah, this is a negative, right?
Okay.
You can pull out any number. So I
Okay.
can pull out negative half or a 4.
Yeah.
Doesn't matter.
You
As long
solve
as
it.
it's a number.
Yeah, I got your solution, but you solve it in a different way than what's happened into under the homework. He showed me in a different way. I understand this way, your way.
Oh yeah, I don't know what he did, but yeah, you use whatever way you want, as long as it makes sense to you.
Thank you.
Is there any other questions you guys have?
No.
No, I'm good. Just
All right,
that,
guys.
if there's anything to cancel out early, I can always cancel it out. I don't have to show the whole steps through it.
For this one?
No, for the other one. 14.
This guy, right?
Yeah, that guy, yeah.
Oh, you want to look?
You said that we can, because the LN and the EU cancel out each other.
Yeah, just remember this property here. I'll write it for you. Ln of e to the x will always equal x, or e to the ln x is equal to x. So these are inverse functions that will cancel.
Okay.
So if you see ln and e, whatever x is up top, I don't care what it is, it's going to cancel out, leaving you only with, oh, here it is, only with that power, that argument.
Okay.
See what I mean?
Yeah, I understand now.
So yeah, this is better. I just didn't notice it right away.
I didn't know. I didn't catch it at all. I was trying to figure out.
It's all right. I'm sure we're all tired.
Okay, thank you very much.
Thank
Yeah,
you.
no problem. All right, see you guys later.
You gonna post these?
I will. I'll do it tomorrow as early as I can.
That's fine.